Welcome, class, to Lesson 7-4. Today, strong mathematicians can find equivalent fractions using multiplication. You take out your notebook, your pencil, you write down today's date, the name of the lesson, and let's dive right in. So a fraction, notice I got rid of unit fraction, but we still have the numerator and the denominator, some key vocabulary words as we go through our fraction land. So today we're talking about equivalent fractions, and what equivalent means is equal. So we're going to talk about some of these things that we see on here, and how this chart can help us out with finding equivalent fractions. So we have right here 1/3 is equal to 3/9. So if we look right here, here's 1/3 shaded in, this part right here. So we look at where we have ninths, right here's that same line, so we're on the same one, but it's 1, 2, and 3 of them. So realistically, 1/3 is equal to 3/9. Another equivalent fraction is that means if I say I have 1/6 and you say you have 2/12, none of us has more. We actually have the exact same thing. Why? Because here's 1/6 of my green line. Here's my other green line. Notice they're on the same one. Here's 1/6, but here there's 1/12 and 2/12 to make 2/12. And last but not least, as we try to use all the fun numbers on this table, we've got ninths, 2/9. So I have to do this one. Here's the 2/9. Notice there's not a third that matches, not a sixth, not a ninth, not a 12th, not a 15th, but an 18th right here is on that same line. Very close to some of the other ones. But now if we count here, we'd have 1, 2, 3, 4 of them. So we know that 2/9, 1, 2, is equal to 4/18. So you can pause the video right now, write down some of these equivalent fraction pairs, to kind of get that in mind that, yes, sometimes fractions can be equal even though they have different numerators and different denominators. And now, not only can we tell if they're equal, we want to tell whether the fractions are equivalent. So we might say yes, we might say no. So let's find out if that is the case. 1/9 and 2/18. So we find 1/9. Here's 1, here's 18ths right down here. I count 1, 2. Here I have 1, so I have 1/9 is 2/8. Yes, those are equivalent. So I'll put an equal sign, smiley face. The next one we're looking to see if they're equivalent is 3/6 equivalent to 5/9. Well, let's find 3/6. So here's 1, 2, 3/6 is right there. And now we got 5/9, 1. So here's 1, 2, 3, 4, 5 is right here. So they are not equivalent. So actually, 5/9 would be greater than 3/6. So not always going to be the same, but it's going to help us get some ideas of what's going on here. 6/9, we must really been in the ninths today. Here's, well, it was 6, because I already counted 5 of those. And now 15/18. Well, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 right here. Are those lines matched up? They are not matched up. So it looks like that 6/9 is less than 15/18. So the only equivalent fraction of the three that we had was 1/9 equals 2/18. Can you see how they make some connections between how those could be equal? We'll find out as we continue. So what if we had a multiplication chart, which hopefully this chart's actually been in our head, so we can kind of see how does this work. So what we have to do is, to use this chart, we have the fraction of 1/3, which means I'm looking at the 1 and the 3 together, and we want to get to 4/12. Well, 1 times what and 3 times what gives us 4/12. Well, if we look, here's the 4, and here's the 12, so that number of times them, both of them by is 4. So we put a 4 here and a 4 there. Notice 1 times 4 is 4, 3 times 4 is 12, so that gives us a way to fill out the chart. We have 1/3 again, which is great, so I use those same numbers, but we're going to try to get to 9/27. So let's figure out where is 9/27 together on that chart. So we follow the 1 again. We go down to where we see there's 9, and we follow this 1 to get down to 27. And notice we had times them both by 9. We have a 9 here and a 9 there. So 1/3 times, so 1 times 9 is 9, and 3 times 9 is 27. So 1/3 is the equivalent to 9/27. Here we have one. We've got 3 times something equals 30, and 10 times something equals 100. Hopefully, they're just showing out of your head. Yes, I know this, I know this, I know this. That would be the number 10. So 10 times that one. Can we use our chart? Yep, here's 3. Here's our 30 way down there. Here's our 10. Gets us to 100, which gives us the number to multiply them both by of 10 in order to get there. And last but not least, we have 5/8. So we can circle our 5, a different number, circle our 8. We're trying to get to 30 48. So to go, where does it say 30? This should say 48, which means we multiply over. We have to multiply by 6. 5 times 6 gives us 30. 8 times 6 gives us 48. So we know that 5/8 is also equivalent to 30 48. So you can pause the video right now, write down those problems. And realistically, you probably realize you could do all of this in your head without the multiplication chart. But it was there as a guide to show you how does this chart actually work to help us find equivalent fractions. And now here's the goal. Find 2 equivalent fractions to the given fraction. So 3/4 is equal to, the great news is there are millions of possibilities, but I'm only asking for 2. So the big thing is that when we find equivalent fractions, what we know from our last page, as we go back, whatever we multiply the numerator by, it has to be exactly the same thing as we multiply the denominator. So with this, let's say we want to multiply by 7s. Why not? 3 times 7 is 21. 4 times 7 is 28. So 3/4 is equivalent to 21 28ths, which is also then equal to, we can go back to our 3/7 again, and this time we're going to times them by, we'll go with the red color, we'll times them by 3. Why not? So 3 times 3 is 9, 4 times 3 is 12, so 3/4 is equal to 21 28ths, which is also equal to 9 12ths. So notice a lot of fractions can be equal to each other. And with that, if you want to try to pause the video ahead and see if you can guess what numbers I'm going to guess, I'll be fair. From 1, I can't use 1, from 2 to 10. See if you can guess what numbers I'm going to choose. So pause the video, write down your equivalent fractions right now, and we will compare answers and see if you were able to read my mind. All right, the next one. We have 5 times 4, which gives me 20 24ths. Did you choose that one? I don't know. Let's see. You got one more chance. I have to do 2 of them. Also another one. I'm not going to use times 4. I'm going to times it by 5 times. Let's see. I did a 3, a 4. That we're going to go with 5 times 5. That's right. So 5 times 5 is 25. 6 times 5 is 30. So notice 5 6 is equal to 20 24ths. It's also equal to 25 30ths. Remember, as long as we times the numerator and the denominator by the same number, we can find equivalent fractions. And here you go, 7/9. Pause it. Put 2 equivalent fractions. Can you read Mr. Camian's mind? And here we go. I hope if you can, that's kind of scary, but we'll see what happens. 7 times 2. I'm taking the easy way out because you probably said this is a really, let me take the easy way, Mr. Camian. I'll give you 2. We have a 3, a 4, 5, and then I'm going to do 6. 7 times 6 is 42. 9 times 6 is 54. So there are all some equivalent fractions to 7/9, 5 6, and 3/4. So you pause the video unless you've already done this because you made your own predictions. And you, even if you have the right number, but I don't have those listed, as long as the numerator and the denominator were times by the same number, I trust you. And when you take a picture of your work, I'll see it anyways. Here we go, box 3, now your turn. Here's where you have to showcase your work. Tell what fractions are equivalent. Is 2/3 the same as 10/15? Is 5 6 the same as 9/12? If not, tell me which one is bigger or less than, or sorry, greater than or less than 2/9 or 4/18. So you can pause the video right now, solve those problems. Make sure you draw a big line right box 3, now your turn, so you can easily identify your work. Here's another one. Can you solve what numbers you need to put into these problems to make them equivalent fractions? So what number you have to multiply both the numerator and the denominator by? Last but not least, find two equivalent fractions for the given fraction of 4/7, 6/12, and 8/15. I look forward to seeing all of your work on equivalent fractions. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. Also, any strategies that helped you, make sure you share those as well. And thanks again for another great lesson.